Dear students, in this module we will discuss and comprehend about the sampling methods with special reference to probability sampling, by which you will be able to have knowledge about different sampling methods. The learning objectives pertaining to this module are sampling meaning and importance and principles of sampling, probability sampling and its different types such as simple random, systematic, stratified, cluster and multi-stage sampling techniques, advantages and disadvantages of different probability sampling methods. First, we will understand the meaning and importance of sampling. In social science research, sampling plays an important role as most of the research is based on smaller representation of a large whole. Researchers generally select small numbers from large populations in which they are interested to study and try to specify the findings from the study to the respectable populations from which the sample was selected. However, selection of sample has to be done on certain scientifically based principles. First, we will see some of the basic concepts of sampling. A sample is a smaller representation of large whole. It is the procedure by which a section of the population selected in such a way that the sample is representative of the larger population. For example, selection of populations for research such as young persons, women, men, workers, elderly persons, etc. from an area and or country as a whole following certain sampling procedures. Sample frame, it is the list of the total number of units or elements in the universe of population to be studied. For example, the list of students in a college based on their broad disciplines like arts, sciences, social sciences, etc. Like other one is a list of households in a village, town, district, state, etc. and number of women who are in reproductive ages like 15 to 44 or 49 years in a village, town, district, state, etc. Now, we will come to the sampling. It is a technique or a method of selecting a sample, that is the fraction of a population from a given population that needs to be studied. In other words, the selection of part of an aggregate or totality on the basis of which a judgment or inference about the aggregate or totality is made. Sampling also can be said to be a process used in statistical analysis in which a predetermined number of observations are taken from a larger population. All sampling techniques are broadly categorized into two types under probability sampling and non-probability sampling. In this module, we will try to highlight the probability sampling methods. So, first we will understand the meaning and importance of probability sampling. Probability sampling is also known as random sampling. Here, random means that every element in the total population, that is study population or target population, has an equal chance or probability of being chosen for the sample, and each of these elements is independent of the other. It is known as the scientific method of selecting samples according to some laws of chance, in which each and every unit of the population has an equal chance of being selected. As these sampling techniques represent the total population, the inferences drawn from such samples can be generalized to the total population from which the sample is selected. Further, some essential statistical tests based upon the theory of probability can be adopted only to data collected from random sample so as to establish correlations or associations between the independent and dependent variables. Now we will try to understand first the types of probability sampling techniques. Some of the following are major types of probability sampling techniques, which are simple random sampling, systematic sampling, stratified random sampling, cluster sampling and multi-stage sampling. We will discuss a few words about each of these sampling methods. First, we will discuss about the simple random sampling. It refers to the sampling technique in which each and every item or each possible combination in the whole population has an equal and independent chance of being included in the sample. Hence, the method is also known as the method of chance selection. This method is also suitable for a small homogeneous population. This method involves careful planning and orderly procedure. Strictly speaking, it refers to the arranging of conditions in such a manner that every item of the whole universe from which we are going to select the sample shall have the same chance of being selected as an other item. The underlying principle of a random sample is that the personal factor is eliminated in the selection of the sample, as the investigator does not exercise his discretion to the choice of items. For the selection of the sample through simple random sampling, firstly, all the sample units or elements in the population from which sample is to be selected have to be listed, that is called sample frame, and then each item or element has to be assigned with numbers starting from 1 to n of all, or at times assigning symbols to them according to requirement. Next, the researcher has to decide the sample size. After that, using one or the other of the following methods, the required sample has to be selected from the list of elements, that is sampling units. Generally, two types of methods are followed to select the sample. Number one, the lottery method. If the sample size is small, say about 10 or 20 out of 100 or so, one can write the numbers of sample units on a piece of paper or slips and then put into a bowl and then pick up one by one without looking into the numbers until the desired sample is achieved. This is also called the fish bowl method. The second type of selecting simple random sampling is using of tables of random numbers. Statisticians have developed several tables based on random numbers. The popular ones are those developed by Tippett, Kendall and Babington, and Fisher and Yates random numbers. For selecting 10 households out of 30, here an example is provided based on random numbers developed by Tippett. By row wise, the selected numbers will be 23, 8, 27, 10, 5, 11, 12, 7, 8 and 26, as these are below 30. However, among these numbers, number 8 has appeared twice. In order to replace one of these, we have to proceed further looking into the numbers below 30, and thereby the next number selected will be 25. From the earlier selected one of the 8 has to be discarded and 25 has to be added. With this, 10 samples have been selected. Similar procedure may be also followed by column wise. If you follow column wise, selected numbers will be 23, 5, 27, 24, 15, 17, 14, 13, 8 and 12. In this case, no duplication is there and therefore 10 sample is selected. One can use any one of these samples for further study. So, now we will move upon the advantages of simple random sample. Simple and easy method and therefore requires less money, time and factor. This method provides a representative sample. Disadvantages wise, in most cases it is difficult to find an up-to-date list of all the units. In the case of a large sample selection, the numbering and ordering of every unit is time consuming and expensive. There is also drawback of possibility of cases selected to be too widely dispersed and hence cost and time would be more. There is possibility of obtaining a poor and misleading sample would also happen, and finally, it is difficult to apply to heterogeneous groups. Now, we will move up on to the next sampling method, that is systematic sampling. Systematic sampling is a type of probability sampling in which every kth item is selected from a list representing a population or stratum. Here too, the list may be prepared in alphabetical order, assigning numbers in ascending order or by the size of the population, etc. Every third, every fifth or every tenth or any other number in like manner can be selected depending upon the sample interval, that is k. Here sample interval or k equals to size of universe divided by size of the sample. For example, suppose we want to select 20 households in which elderly, that is 60 years and above persons are residing out of 100 households. The sample interval would be 100 by 20, that is 5. Then the first number has to be selected on random basis from 1 to 5. The next numbers would be selected with the sample interval of 5 till we achieve the desired sample size. In the present context, if the first number selected is 3, then the next numbers are 3, 5, 13, 18, 23, 28, 33, 38, 43, 48, 53, 58, 63, 68, 73, 78, 83, 88, 93 and 98. Like that 20 sample have been selected. For the application of this sample, firstly a list of all the elements and numbering has to be done. However, the population needs to be homogeneous in nature along some particular characteristic of interest, like elderly persons or students or women in reproductive ages or women who have children under 1 year of age, widowed women, etc. The advantageous side of systematic sampling: it is simple, direct and less expensive. If the list of items is available, this method is an efficient and economical approach. Disadvantageous side: exact mathematical procedure for estimating the precision of the systematic sample does not seem to be available, not possible to use in the case of unfamiliar area of study because the listing of elements is not possible, and if the universe is not homogeneous along some particular characteristic, the sample selected may become wrong since it is not systematic. Now we will move upon to the next type of probability sampling, that is stratified random sampling. Under this sampling procedure, the entire population or universe will be divided into a number of homogeneous groups or strata based on some common characteristics. Then the required sample will be selected based on simple random or systematic sampling methods from the total of each of the strata or homogeneous groups. The commonly used stratum characteristics are gender, like male or female, place of residence like rural or urban, caste groups like scheduled caste and non-scheduled caste, elderly population by age like young old, old, etc. Mostly the subgroups will be 2 or 3 numbers only. This sample method is also of 2 types: stratified proportionate sampling and stratified disproportionate sampling. We will see the basic features of stratified proportionate sampling. In this method, the number of sample units from which each stratum will be selected based on its proportion in the total population. For example, suppose one wants to select a total sample of 20 out of 50 based on 2 strata, that is males and females, then one has to look into the proportion of males and females in the total population under consideration. Say for example, out of 50 persons there are 30 males and 20 females, and the researcher has to compute the proportion of male and female to total population, like 30 by 50, that is 0.6% for male, and 20 by 50 is about 0.4 for females. Then these proportions have to be applied to the sample the researcher intended to select, like 20 into 0.6 equals to 12 males and 20 into 0.5 equals to 8 females. Thus, the total sample of 20, of which 12 are males, 2 females would be selected out of 30 males and 20 females respectively. This sort of sampling would give equal representation to the strata under consideration. Stratified sampling method is stratified disproportionate sampling. In this method, consideration is not given to the size of the stratum. Instead, the researcher may select an equal number or have some other criteria by which to select from the strata under consideration. In the previous example, the researcher may select either 10 each of the males and females or 15 males and 5 females, irrespective of their proportion to the sample. Hence, this method is coined as disproportionate random sampling. In both the cases, the point to be borne in mind is that the selection of the sample from strata would be mostly based on the simple random sampling method. At times, in the case of large samples, systematic sampling method also be used. Advantages wise, samples selected from each group are sure to have representativeness. Greater precision saves time and processing of the data. Geographically more concentrated and thereby save time, money and energy. For comparative studies, it is more suitable method. Disadvantages side, unless extreme differences are there between the strata, the expected proportional representation would be small. Even after stratification, simple random or systematic sampling techniques have to be adopted for the selection of the sample, and thereby the drawbacks of either of these will be there. One must know the characteristics of the specified population on which the study is to be made, like homogeneous groups along some particular characteristics. In social sciences, we are mostly interested in measuring several variables. A variable advantageous to one type of stratification may not be suitable for another one. Next probability sampling type of technique is the cluster sampling. Like in the case of the stratified sampling method, here too the universe is divided into several subgroups, generally homogeneous in nature, based on visible or usually identifiable characteristics, which are called as clusters, and then these clusters will be selected based on the simple random sampling instead. Here, elements are not selected from each stratum as is done in stratified sampling. Rather, the cluster or its elements are obtained by taking a sample of groups and then sample will be selected within the groups. This means that out of selected clusters or groups, 1, 2 or more number of clusters are selected and all elements are studied, or at a time or at times the sample elements may be selected by simple or stratified random sampling methods from the clusters. The number of elements in a cluster is called the cluster size. For example, suppose a researcher wants to select elderly persons from an urban area. Then at the first stage, all the wards and or streets have to be divided into clusters of given the number of households, namely 100 or 200 based on the door numbers. At the next stage, the researcher has to select the number of clusters, that is streets or parts of streets in the wards of the city with a given number of households, with the application of simple random or stratified sampling methods. In the next stage, the sample units or households in the present condition will be selected again in applying simple random or systematic random sampling. However, if the clusters are smaller in size, one can go for census enumeration, that is only those households in which elderly persons are living. Instead, for applying any sampling methods, if the researcher knows the approximate number of elements, one would be likely to get, say for example, in the present condition, the researcher knows that out of 250 households, there is the probability of getting a sample of 80 elderly approximately. This is based on the census information that about 8% of the population is elderly in the selected city. Therefore, 250 households into 4 persons per household, 1000 population by 0.8%, it will come 80. That is, out of 1000 population wherein 250 households are there, there is possibility of 80 elderly persons are likely to get. So, depending upon the required sample size, the clusters may be selected in anticipation of getting a sample of 80 households, that is wherein elderly live per cluster. The advantages side of cluster sampling: this method is much easier and more convenient in apply when large population or large geographical areas are covered. The cost and time of this method is very less. It promotes the convenience of field work. Units of study can be totally substituted for other units within the same random cluster. It is more flexible. It can be used in situations where it is impossible to obtain a sample by other methods. Disadvantages side: the size of clusters may vary, which could increase the bias in sample selection. It is a complicated sample design and sampling errors may be greater. Adjacent units of study tend to have some more similar characteristic than do units distantly apart. This affects the representation. Now, the next probability sampling technique is multi-stage or area sampling. As the name implies, this method refers to a sampling procedure which is carried out in several stages, generally more than 2 stages. The population or universe from which sample elements are going to be selected will be classified into first stage, second stage and third stage units, and generally at each stage sampling methods will be applied, but at the final stage only the sample units will be selected. For example, suppose one wants to study the fertility behavior of slum dwellers. Cities will become the first stage units, slum areas form the second stage units, and then within the slum areas women of reproductive age form the sample unit, that is units or respondents. Normally, a multi-stage sampling procedure is one that combines cluster and stratified sampling methods. When the clusters are successive geographical units, the sample design is a special form of multi-stage sampling which is known as area sampling. For example, in a nation level survey, the selection of sample at the country level has been done on the following lines. At first, from India, states have been selected, then from states, districts have been selected, then from districts, towns and villages have been selected. After that, from towns and villages, wards and or streets, they are called clusters of 300 households have been selected, and finally from these wards and or streets, that is they are clusters, women of reproductive age between 15 to 49 years have been selected. Sampling is done at the stages of selecting clusters as well as women of reproductive ages. Advantages side of multiple stage sampling: it results in concentration of field work in compact small areas and thereby saves time, labor and money. It is more convenient, efficient and flexible than single stage sampling. It prevents the necessity of having an exact sampling frame at each stage like India, state, district, towns and villages under consideration, as it covers entire population rather than sampling units. Disadvantages side: procedure of estimating the sampling error is difficult because prior information about the sample frame and size is not known. Likewise, estimating cost advantage is also complicated as it needs advanced information about the sample area, sample characteristics and how to reach a sample, etc. For non-statisticians, it is difficult to follow this procedure as one needs to estimate the sample size, sampling, standard errors, etc., which are too technical for social science researchers. In sum, in this module, so far we have discussed and learned about the probability sampling methods like simple random, systematic, stratified, cluster and multi-stage sampling techniques. Procedures of selecting samples through these techniques with examples and advantages and disadvantages of these techniques in selecting the sample also have been learned. Hope after learning about all these sampling techniques, you will be able to choose an apt probability sampling technique for selecting the sample to your research study. Thank you.